Hello everyone, welcome back to the channel Campus Coders. Today we are going to see a new question, an interesting question. Here they are given an array. We need to find the length of longest subarray with the given sum k. So if there is an array given and they are given an integer, let's say here 3, we need to find the longest sub length of the longest subarray whose sum is equal to 3. So the normal approach for this question would be finding all the possible subarrays and its sum and check if the sum is equal to 3, and then all those subarrays whose sum is equal to 3 we need to find whose length is maximum. We are going to return the length. So this would be the brute force approach. Let's first try to code the brute force approach itself. So first, how can we find the all the possible subarrays? So subarrays are nothing but all the partial arrays which we can find from a given array, right? So let's take two pointers. Okay, let's say it would be I and then J, and let I and J be the starting point and ending point of each subarray respectively. So we can say that if let's start from the first index, 1 is itself a subarray, right? So I and J will be at 1 itself. Then 1 and 2 will be a subarray. 1, 2, 3 will be a subarray. 1, 2, 3, 1 will be subarrays. Likewise, we're going to find all the subarrays that start with this integer, right? This index. The similar way we can say from starting to 2, 2 to 3, 2 to 1, 2 to 1. So there will be a lot of subarrays like this. So we can say that for int I equal to 0, I less than n, I plus plus. Since the starting array is going to be from the first index till the end of the array, right? And then the ending index will be from I, because ending will not be less than the starting index, right? So it starts from I and then it goes till the end of the array. So J plus plus, right? So we have found all the subarrays. We have traversed all the subarrays. So let's say we are having starting as 3 and ending here as maybe 4. Okay. So if we have these two as starting and ending, how can we find the sum of this subarray? Obviously, it's going to be another pointer, right? So another loop basically. So to find that, let's say int sum is equal to 0, first we initialize it, and then to find the sum of that subarray, we can say int k equals to I. It starts from the index I, and k less than equal to j, and k plus plus. I hope you can get this. So at this loop, we are going to find the sum. So sum plus e equals to array of k, right? So after finding the sum, we are going to check if this sum is equal to the final, the target which we are going to check. If this is equal to sum, we are going to check if this length is equal to is greater than the previous length. So here the length of this subarray will be j minus I plus 1, because this is zero based indexing. So let's take an example here from here itself. This I is equal to 2, right? The index of I is 2, and then the similar way j will be 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Yes, 7. So this length of subarray will be 7 minus 2, 5 plus 1, 6, right? So 1, 2, 3, 4, 5, 6. 6 is the length of this subarray. So the length of subarray will be j minus I plus 1. We are going to check if this is greater than the previous maximum length which we are finding. So if this is greater, then we are going to increment the maximum, and then we are going to return the maximum length. This is the brute force approach, you can say. So in this approach, you can say like this is not the best approach because this takes O of n cubed complexity, right? So to optimize this for first, we can say like here we are using another pointer k, right? This is for finding the sum of that subarray. If I increases, j also increases, k is increasing from I to j. So this one we can optimize it like we will take I as the starting index as such, and for every j which we are finding at that time itself we can find it sum as well, right? Instead of taking another pointer, we can use j pointer as the ending index as well as finding the sum of each index, right? So I will code this so that you can understand it better. So for first, this starting index will be the same, and we will initialize the sum here itself in sum is equal to 0, and now in j is equal to I, j less than n, j, j plus plus. So I is all possible starting index, and j here will be the ending index of the subarray as well as the current element of the subarray, right? So here we will say sum plus equal to a of j, and then here we can find again sum. If sum is equal to k, len is equal to max of len comma j minus I plus 1. The same thing we are going to do, and then return len. So we have just optimized this O of n cube to O of n square. I hope this you got this. Whenever we are incrementing, we are having I as the starting index, and we are going to check each and every j index. While we are progressing to each and every pointer, we are going to check its sum as well. Progressively, we are going to check its sum as well. Whenever the sum is going to be equal to the length, we are going to check the maximum length, and then we are going to update that length variable, right? That's it. So this is also of n square. To optimize this further, we are going to use another method that's called hash map, right? So to explain this, I will just give you the dry run of that uh, method. Okay, let's take 1 2 3 1 1 1 1 4 2 3. This is the array which we have right now, right? To in this array, in the previous step we have two pointers. First pointer is for starting index, second pointer is for ending index, and we have used that as for sum as well, right? So here what we are going to do is we are going to have only one indexing, right? Only one start the index that's going to be the starting index. So it will be I, and then we are going to uh, progressively increase, that means traverse every elements of the array. So and then get its sum first. We are going to find the prefix sum. The same what we are going to do here, we are going to do only for the first using one pointer, and then we are going to check it. So basically we are going to have this as start pointer, and then going to check what's the sum of 1 and 2, what is the sum of 1 and 3, 1 2 3 1 2 3 1 1 2 3 1 1. So we are going to check, and then at that point when we are getting, if the sum is equal to the target, we are going to find it, right? But this way we are going to check for only for subarrays that has starting index of 1. What about if the answer is, let's say here the required target is 3, right? Some required target sum is 3, so this possible so maximum subarray will be here. This is in middle. So to find the sum of a subarray that's in between the array, we are going to use hash map, right? So I will tell you the how this is going to be working. So let's take first prefix sum, and then we are going to take length, the maximum length. We are going to check these things, and then we will have a hash map here. We will have a hash map here. So first, let's initialize prefix sum as 0. Okay, and then we will have an indexing as well here, so that we will get an idea how this is going. What are the index here? 0, 1, 2. Okay, let's just have it as such. It's not a very big thing. So we will have prefix sum as 0, and we will take first in first element. Okay, so first element is 1, so prefix sum is going to be 0 plus 1, 1. Okay, and 1 is not equal to 3, right? So we are going to, so since 1 is not equal to 3, okay, we will have the required target sum as well. Okay, k is equal to 3, right? So since 1 is not equal to 3, we are going to increase the pointer. It's going to be here. And then since this is the pointer, we are going to increment the prefix sum as well. Now it's going to be 3. Now 3 is, so before incrementing the pointer, since 1 is not here, 1 is not in the hash map, we are going to add this into the hash map, right? 1 comma 0, right? 0 is nothing but the index. So 1 is the element, 0 is the index. We are going to increment here. So then we are going to the next element, that is 2, and we are going to increment the prefix sum, that is 3. And since 3 is equal to the target element, we are going to increment the length. Initially it will be 0, and we are going to increase it to 2, right? Since there are two elements, we are going to increase it to 2. So this is the maximum subarray till now. Okay, and we are going to move on to next element. Now it's 3, and prefix sum will be 6. Now comes the thing, since it is greater than the element, so now 6 is greater than 3. So now we will check. There are three elements, right? Let's say there are three elements. Now there is one element, there exists one 3, right? One target sum. That means there will be another target sum as well, right? Within that subarray itself. That's 3. That means we are finding the other remaining sum here. So that in the overall 6, the element will be there. There will be a remaining sum as well, 3. So if we check the remaining, if that is in the hash map, right? So we are actually, I forgot to add this in the hash map. We already got the prefix and 3, right? We're going to here add this as well, 3 comma 1. Before moving to next element, we are going to add it in the hash map. So 3 will be added, and then that's in the first index, so 3 comma 1. So when we are moving on to the next pointer, we have 3 here. We are incrementing the prefix sum to 6, and since here 6 has the the element has 3, and then the other remaining subarray 3, we are going to check the remainder if it is in the subarray. Since it is in the subarray, we are going to see, we are going to check this 3, what is the length of this one. Since this length is 1, which is less than the previous 2, we are just going to leave this part, right? Because we need the longest subarray with the sum. If you got it, it's okay. If you are not, if you didn't get this, we can just go through that right, and then the next steps we will be able to understand, right? So just clear this off first. Now 3 is already there in the element, so we are going not going to do anything here. So now it will be 6, right? So we are going to add this 6 comma 2 in the hash map. Hash map, we are adding the prefix sum as well as the index. That's what we are going to add. And then moving on to next pointer, it's 7. uh, the prefix sum will be 7. And now for this 7, we have, let's say here we have 4 elements. We will take those 4 elements, and then total sum is 7, right? Total sum is 7. We we need 3, so we need 3, and then the remaining there would be 4 If we need three, the subarray with some three, the sum of the remaining subarray will be 4 within this subarray, right? So in the subarray which we are taking, we are going to split it into two subarrays. One will be the required sum, the other will be the rest sum. We are going to find the rest sum. Rest sum is actually 4 here. Since 4 is not in the hash map, we are just going to leave it as such, right? So this case we are not going to do anything. We're just going to add it in the subarray 7 comma 3, right? 7 comma 3, we're adding it this in the subarray. So 7, we're going to next pointer, it's 8 here. And now here in this part, again we are going to see 1 2. Okay, instead of just doing this one, we can just say in the subarray 8 we need the sum of 3. Okay, let's say there exists some subarray with sum 3. The what is the rest sum subarray? That will be 8 minus 3 5. Is 5 is in this hash map? No. So we are going to leave this one as well. So we are going to increment to next element, that is 9 now. And 9 here again, 1 2 3 4 5 6. There are 6 elements with sum 9 right now. And then we need sum of 3. So the rest sum would be 6. Is 6 in the hash map? Yes. So 6 is in the hash map here. So if 6 is in the hash map, we are going to check what is the length of this 3 element, right? So the last 3 elements is the subarray right here. The last 3 is the sum. So length is equal to 3, which is greater than 2. So we are going to increment 2 to 3. So now I hope you got this. Just the same way we are going to do the for the next rest of the elements, and if you do it, you won't get a length greater than 3. So finally, this will be the answer. This is the approach we are going to do. So once we will code this question, this method, so that you will get an idea. So let's say uh, it's let it be long int longest sub array, right? So it will have int arr int k. So here let's first initialize the map long comma int pre sum map. Okay, so here the sum, first we need to find the sum, right? So let's take sum is equal to 0, and then int max length equals to 0. Okay, so for int I equal to 0, I less than n, I plus plus to traverse through this array, right? And we are going to find the prefix sum. So we are going to add each and every elements here. The first thing which we have seen is if that sum is equal to the required one. If it is so, we are going to increment, we are going to update the max length. So max length comma I plus 1. Since it is 0 based index, we are going to increase the index, right? After checking this, we are going to check the remaining, right? Remind, let's say it's, let it say it be int remaining is equal to sum minus k. So this will be the sum of remaining subarray, and we are going to check if this remainder is present at the presum. Okay, it will be like presum sum map dot find m presum map dot end. Okay, this means if remainder exists in the map hash map. Okay, if it is so, what we are going to do is to find the length of that. Okay, so int length is equal to I minus pre sum map of frame. and then we are going to increment the check if it is the maximum length. Okay, maximum comma length. And then we are going to change the we are going to add this into the hash map. So pre-sum map of sum will be equal to height, right? And then return max. Yeah, this is the method, but there is one edge case which we need to check here.